Well, hey everyone, welcome to Honors Geometry, section 2.7, segment proofs reference, okay? So we're doing segment proofs today. So our SWBA students will be able to prove statements about congruence, section 2.7. Once again, the nice part about these videos is you can pause them as you need to or skip forward as you need to, rewind, do whatever you need. And if ever during a video, if you're watching it in class, feel free to pause it and come up and ask me a question about something. All right, well, we have our properties of equality that I'm going to review from last time here, okay? So we have the addition property, subtraction, multiplication, so on and so forth from 2.6. Those are all carrying over. And just a reminder on those reflexive, symmetric, and transitive, because we can confuse those. Reflexive is like something equals itself. So that's like 8 is equal to 8, okay? Symmetric is where we flip it around. So like x equals 8, or y equals 8, I guess I wrote there, but x equals 8, and 8 equals x. Okay, so those would be the same thing there, okay? And the transitive is saying like, hey, x equals y, y equals z, so thus x equals z. Kind of like the law of syllogism. So these can only may only be used with equal signs, but we also have them with congruence. Now, personally, I'm not going to actually stress over whether or not you say the reflexive property of equality or reflexive property of congruence, but it's really the same idea. It's just saying for any segment AB, you can have segment AB is congruent to segment AB. So we're saying not only does the reflexive property exist for equality, it also exists for congruence. If something's congruent, or any segment is congruent to itself. Same idea with symmetric property. We can have the property of equality or congruence. Once again, I'm really not going to be concerned whether or not you say the of equality or of congruence on these, okay? So we can have segment AB is congruent to segment CD. Well, then also, we have segment CD is congruent to segment AB. Transitive property, once again, same idea as what we had on our equality, but this one's just for congruence. So if we have segment AB is congruent to segment CD, and if we have segment CD is congruent to a segment OEF, I kind of said O, but it's like OH. It's like OEF, okay? And then segment AB is congruent to segment EF. Kind of cut out the middleman, segment CD, okay? So all those properties of equality, these three also apply to the properties of congruence. Now the other ones, the addition, subtraction, so on and so forth, only apply to equality there, okay? So you have to be careful with that. Substitution, though, can apply to congruence, but it's very similar to just the transitive property. So we have some more definitions we're going to talk about here. As we said in our proofs, we can also use definitions as well as properties. So definition of congruence. So if you think about defining something, it's just what it means. So statements are congruent if and only if they have the same measure. That's our definition. And if you notice, this is actually a biconditional with that if and only if there. So we'll say, okay, let's say if segment AB is congruent to segment CD. Well, that would mean that the measure of segment AB is equal to the measure of segment CD. So if the two segments are congruent, they're equal. The measures are equal, excuse me. That's our definition of congruence. But since it's a biconditional, it goes both directions. So we can also say the converse. If the measure of segment AB is congruent to the is equal to the measure of segment CD, well then those two segments have to be congruent. So if you're ever switching between things being congruent and things being the measures being equal, and then the actual pieces themselves being congruent, that's going to be our definition of congruence, because that's just what congruent means, hence definition. So definition of midpoint, well, midpoint, the definition of that is the midpoint of a segment divides the segment into two congruent parts, or equal parts. So if M is the midpoint of segment AB, well then, we know that the measure of segment AM, it's a really bad M. That was somehow an even worse M. Measure of segment AM is going to be equal to the measure of segment, make this thing go away, BM. So we're saying, hey, if M is the midpoint, then it has to cut it in half. So A to M is going to be the same length as B to M. Once again, that just goes back to what midpoint meant from chapter 1. Segment addition postulate, we talked about this the other day. We talked about this last chapter, not the other day. If A, B, and C are collinear points, so they're on the same line, and B is between A and C, as we see here, then we know that the measure of segment AB plus the measure of segment BC will equal what? It'll equal the measure of segment AC. We can add the two parts to get the whole. Continuing on here with our notes. So we're going to practice some of these. So just like we practiced some of these properties the other day in section 2.6, we're going to practice some of these here as well, okay? So feel free to try and work ahead and then kind of pause the video to do that, and then see what I get compared to what you have. So if PQ is equal to PQ, and heads up, in this note packet, it's the same thing to say measure of segment PQ as it is just to say PQ, because when you say those, just the PQ equals PQ, it is implied that you are asking about the measure of that segment. So heads up, it is implied they're asking about the measure of the segment, aka the distance between those 2 points. This is like saying, hey, the measure of segment PQ is equal to the measure of segment PQ, then those two segments are congruent. Now they happen to be the same one, so we might be thinking reflexive property. But we have to dive in a little bit deeper and say, okay, well, if the measures are equal, then those two segments are congruent. That's going to be our definition, or I'll just abbreviate as def, of congruence. Saying, hey, if the measures are equal, then the segments are congruent, or vice versa, the other way around. If K is between J and L, then JK plus KL equals JL. So the measure of segment JK plus the measure of segment KL will equal the measure of segment JL. That's going to be our segment addition postulate. And you'll see how I shorten that down here. Into seg add post. I call it segment addition postulate. Segment EF is congruent to segment EF. Well, that's going to be our reflexive property. And that technically is the reflexive property of congruence, but once again, I'm not going to be concerned whether or not you say congruence or equality, really. I just want you guys to know that it is the reflexive property. If segment RS is measure of segment RS is equal to the measure of segment TU, then the measure of segment RS plus the measure of segment XY equals the measure of segment TU plus the measure of segment XY. Well, what happened here from the first part to the second part? Well, we had two things being equal, the measures, and we said, okay, if we add XY to both sides, if we add the same measurement to both sides, it stays equal. Well, this is actually going to be our addition property of equality. No matter, I do want us to say of equality on those addition, subtraction properties, and so on and so forth. Now you might be saying, Mr. Cross, I thought those didn't work for segments. Well, it doesn't work for things being congruent, but here we're talking about the measures, so it works because it's equal signs equality. If segment AB equals segment DE, then segment DE equals segment AB. That is going to be our symmetric property. Continuing on to the ones below this. Number 5, if y is the midpoint of segment XZ, then XY is equal to YZ, so those measures would be equal. Once again, that's going to be our definition of midpoint. A big hint here on our definitions. So as we see a lot of definitions moving forward, and we'll see more definitions going forward, but as we see those, if we're going from a lot of words, if y is the midpoint of segment XZ, go from words to math. We see an equal sign there, two things being equal. I consider that more math. Maybe you wouldn't because there's a lot of letters there instead of numbers. But when we go words to math or math to words, it's a big hint. It's probably a definition, okay? So just a heads up. And then for what kind of definition? Well, it says the word midpoint. Okay, as I cross that out instead of underline it. Okay, it says the word midpoint. Okay, so we'll be talking about the definition of midpoint. If segment FG is congruent to segment HI, and segment HI is congruent to segment JK, then segment FG is congruent to segment JK. Well, they're both congruent to segment HI, so now they're congruent to each other. Kind of cut out the middleman, segment HI, so this is our transitive property. if segment AB plus segment CD equals measurement of segment EF plus measurement of segment CD, well then measurement of segment AB equals measurement of segment EF. Well, from this first equation, second equation, we lost the segment CD on both sides. So what happened to it? Well, it subtracted from both sides, and they end up zeroing out, so we didn't have it anymore. So this is our subtraction property of equality, saying that, hey, if we subtract the same thing from both sides of the equation, it's okay. So the subtraction property, once again, of equality is what I want us to write on this. Oh, this pen will acts up every now and then. All right, 9. So if measurement of segment PQ plus measurement of segment RS equals measurement of segment TV, and measurement of segment RS equals measurement of WX, well then measurement of segment PQ plus measurement of segment WX equals a measurement of segment TV. Wow, that is a mouthful. So we look, well, we're given the fact that these two add up to equal TV, and these two segments have the equal measure. So we said, okay, what about this new equation? What changed between our first equation and our second equation? Well, segment RS is now segment WX. Why are we able to make that change? Because they're equal. If two things are equal, you can replace one for the other. That is our substitution property. So we're going to put substitution property. If segment LP is congruent to segment PN, or excuse me, the segment measurement of segment LP is equal to the measurement of segment PN, and L, P, and N are all collinear, then P is the midpoint of segment LN. So once again, earlier I said that definitions can go either way, and if we go from a lot of words to math, or math to a lot of words, it's probably a definition. So it's a definition here. And what definition do we see? Well, we look at the sentence. Midpoint. Definition of midpoint here. Saying, yeah, if these two segments are equal measure, and all these points are collinear, well, we notice P, L to P, P to N. So the whole segment's Ln there. P is the midpoint. If segment UV is congruent to segment UV, then the measurement of segment UV is equal to the measurement of segment UV. Well, we go from something being congruent to the same things being equal. It's the exact opposite we had on number 1, actually. The reverse order, the converse order. So this is the definition of congruence. But Mr. Costle, this didn't go words to math, math to words like the other definition. Yep, the definition of congruence is our one exception to that words to math or math to words kind of guideline. 12, measurement of segment CD plus measurement of segment DE equals measurement of segment CE. Then, measurement of segment CD equals measurement of segment CE minus measurement of segment DE. So what happened from here to here? Well, we lost segment DE and we gained a negative one here. So if we subtract segment CD from both of these sides, measurement, we'd end up getting this equation. So this is our subtraction property of equality. Kind of a tricky one there to see it. We have to remember that those measurements of those segments are really numbers. But we're just saying the measurement of whatever that segment is because we don't know it. Continuing on. Here's the segment proofs guide. It's in your packet as well. It's copied twice, but it's really just the same thing both times. It's just twice on there to fill up the whole page, I suppose. Whoops. And so on like box 1 will correlate with number 1 that we're about to do. 2 will correlate with 2, 3 with 3, so on and so forth. So let's look at number 1 here. And I put it on this the video as well on the slide so for easy reference for us. So we're doing these 2-column proofs again here, okay? Now instead of doing these 2-column proofs with algebra equations, we're going to start doing them with segments. We're going to prove things about segments here. So we're told that segment or point E is the midpoint of segment DF. That's our given. So that's going to go in our first statement. Then we're given all the left side. We're told all the left side here, and we're asked to prove that if we take twice the measure of segment DE, we double that measure, we'll get the measure of segment DF. And we have this picture here to help us. We're saying if we take twice this measurement, we'll get the whole thing. And we have to prove that by saying, well, just from the fact that we know that E is the midpoint. So here are the steps we go through. We need to give the reasons why, and we'll use each of these exactly once. So our first one, well, that's our kind of a freebie. It's our given. It was given to us. So from this, we went words to math. That should be a big hint for us that it should be a definition, and there's only one on there. Another way we can know is saying, okay, well, if we know E is the midpoint here, well, we can maybe mark on our picture, if E is the midpoint, we should know these to be congruent, or they have equal measure. So now we're told segment DE has an equal measure to segment EF. And so, oh, okay, that is definition of midpoint that we can know that. Because of what the word midpoint means in math and geometry here, we know that to be true. Now, from this equation to this equation, what changes? Well, we have we're adding something now. And we have, oh, excuse me, let me cross this out. We're adding something now, and then we're adding segment D on this side. So we added the same thing to both sides of the equation. And that's okay because of the addition property of equality. Might be wondering why that math move happened there, why we're adding that. And I'll get into that in a bit. But first of all, it's concerned of how it's okay that we do that. Now we're saying segment DE plus segment DE would give 2 times segment DE, and the right side remains unchanged. Well, that's really just combining like terms, saying, hey, if this was like x, for example, and this was x, we can call it 2x. Same idea, but with the measurement of segment DE. So this is actually just going to be our simplifying. So that's simplify or combine like terms. Now we have segment measurement of segment DE plus measurement of segment EF is equal to the measurement of segment DF. Well, what changed here? Well, actually nothing changed necessarily from one of these previous equations. It's actually something new. We have to look back up at our picture. So if you're ever stuck, it doesn't look like it followed our train of thought, look back up at our picture. If I take segment DE, this left side, and I take segment EF, this right side, and I add them together, would I get the whole thing? Yeah, and that is called our segment addition postulate back from section or chapter 1. The segment addition postulate, or as I abbreviate it, SAGAD post. So now we're going to say 2 times the segment measurement of segment DE is equal to the measurement of segment DF, which is what we're trying to prove. So how can we go about that? Well, if you look earlier, we have 2 times the segment of DE is equal to DE plus EF. DE plus EF is equal to DF. So we can kind of cut out the middleman and go straight from 2 times the segment DE is equal to 2 times the measurement of segment DF. And that would be our transitive property to cut out the middleman, so to speak. So on number 2, we have this picture of these segments here, segment KM, segment LN intersecting here. And we're given that segment KL is congruent to segment LN, segment LM is congruent to segment LN. We're trying to prove that L is the midpoint of segment KN. So we have all of our givens here in the first statement. So we're going to write that is given to us. Now something I think that is helpful as well is not only writing down the given, but marking it on the picture. So KL is congruent to segment LN. If we recall, we can do tick marks. And segment LM is congruent to segment LN. Well, LN already has 1 tick mark, so we don't need to put another one on there. But since those are congruent, we can put another tick marks. Now we might notice from this picture that it looks like segments KL and segment LM are congruent. And we'll actually get to that in step 3 that their measures are equal, okay? We'll see the steps that get us there besides saying, oh, well, we can tell on our picture, but here's the actual step-by-step process to prove it correct. So from step 1 to step 2, we have the exact same things here as above, except for now instead of the segments being congruent, their measures are equal. So whenever we go from the segments being congruent to measures being equal, or vice versa, that's going to be our definition of congruence. So now we're saying, okay, well, segment KL has a measure equal to measure segment LN. Measure segment LM has a measure segment LN. So now measure segment KL is equal to the measurement of segment LN. Well, that would be our transitive property saying, hey, if they both have an equal measure to LN, they're equal to each other. So that's our transitive property. And last but not least, I know we could just fill in the blank and know what it is. I crossed out the wrong definition earlier, didn't I? You guys probably caught that. I just caught it. My bad. I should cross out definition of congruence. But now with definition of midpoint, this one does stay true to most definitions where it goes from some math, equal sign here, to words. L is the midpoint of KM. And to help us know what word we're talking about, midpoint. So it is the definition of midpoint, saying, hey, if measure of segment KL is equal to measure of segment LM, L has to be halfway between them. It has to be the middle. Oh, I also undid that transitive property on accident. Okay, so L is the midpoint, so that is definition of midpoint. On number 3, we have these two segments. Segment PQ is congruent to segment TQ. Segment UQ is congruent to segment QS. We're given all of that, so we're going to say it's given to us. We'll go down here, say given, and let's mark it on our picture. Segment PQ is congruent to segment TQ. Segment UQ, I'll have to use 2 tick marks here. It's congruent to segment QS. I'd use 2 tick marks this time because they're not congruent to the ones with 1 tick mark. But we're trying to prove that segment PS is congruent to segment TU. Well, so we went from the segments being congruent to their measures being equal. That's going to be definition of congruence. We're going to have that quite a bit to start with when we're given things being congruent. Definition of congruence, and we see 2 of them, meaning we'll use another one later. Step 2 to step 3. Well, these look quite unrelated to me. So let's look at our picture. Segment PQ plus measure of segment QS equals measure of segment PS. If I take PQ, add it to QS, get the whole thing PS, that looks like the segment addition postulate. We're adding these 2 parts to get the whole thing. Well, segment TQ plus segment QU, TQQ, hey, equals measure of segment TU, that's the same thing. So this is, in fact, the segment addition postulate. So we can cross that one out. Segment TQ, the measurement of segment TQ is plus the measurement of segment QS equals the measurement of segment PS. Well, what happened from 3 to 4? Because we look at the picture, TQ to QS, that doesn't make any sense. Well, we were told earlier that PQ has an equal measure to TQ. And here it looks like we took the first equation, number 3, and everything stayed the same except for measurement segment PQ is now measurement segment TQ. So that's actually our substitution property. We're saying, hey, since those have an equal measurement, we can substitute one measurement for the other. I'm thinking we see that one twice as well, meaning we'll probably use it again. Scratch out, we will use it again. And we'll actually use it right now, because now we have measurement of segment TQ plus measurement of segment QS equals measurement of segment TU. Now, you might be wondering, well, did we just substitute PS for TU? Okay, and actually, because you might be wondering, well, what did we substitute here? When we use substitution property, I'm actually going to have us start putting in parentheses what we substituted. So that way we're clear about it. So I substituted segment PQ for measurement of segment TQ. So I'm going to have us put in parentheses what we substituted, okay? I should have been saying that earlier, and I'm sorry I didn't. But continuing on here, I'm going to have us put in parentheses what we substitute. But we aren't, going back to this, we can't say we substitute PS for TU because we're not told anywhere that those 2 things are equal. In fact, that's what we're trying to get to is saying that they're congruent. So in order to say they're congruent, we would need to say that their measures are equal. So we can't use that substitution. So what are we substituting? Okay, we know we are substituting something, but what is it? So we'll be looking at, so we're substituting that TQ plus QU equals TU. That does look a lot like this equation, except for QS is in place of QU. And we look up here, UQ, QU, UQ and QU, those are the same thing. So yeah, UQ for QS, the same thing as QU for QS, so we can substitute those. So we're going back to step 2 again for that. So I'll say UQ or QU, segment UQ or measurement segment QU, is equal to the measurement of segment QS. Let me see if we can substitute those. Now on number 6, measurement segment PS is equal to the measurement segment TU. Well, transitive property, definition congruence. Definition congruence doesn't really make sense there because we're not going from things being equal to things being congruent or vice versa. It's probably transitive property, but let's get some understanding behind why. So if we look at steps 4 and 5, we're told that both measurement segment PS and the measurement segment TU are equal to the same exact addition over here. So that means they're equal to each other, which is the transitive property. And then last but not least, we have two segments having their measures equal. Now we're told the segments are congruent. It's a reverse of step 1 to step 2. So this last step will be the definition of congruence again, because definitions can go both ways. As my pen freaks out. And we finished up number 3. Continuing on here, we have lots and lots of proofs, and we actually won't cover every single one of them right now because there's 12 proofs here. And I don't want you to cover every single one of them, but I want you guys to get an idea and a flavor for these. So let's work on number 4 here, though. So we're told K is the midpoint of JL, and M is the midpoint of segment LM, or LN, excuse me, and that measurement of segment JK is equal to the measurement of segment MN. Okay, well, I'm going to mark some given information here. So measurement, say, JK has an equal measurement to measurement of segment MN. We know that'll mean they'll be congruent, even though if we don't have that information written down yet. And we know K is the midpoint of J to L. Well, we know it's going to mean that J to K and K to L are congruent. And we know since M is the midpoint of LN, that LM and MN are going to be congruent. So let's go ahead and mark our picture there to help us out. Now if we go to our table, that K is the midpoint of JL, M is the midpoint of LN. Those are both given facts. Those are both given facts. Now in step 2, we're almost always going to do something with the given fact. So we go from a bunch of words to things being equal. It's a hint that it's a definition. If we look here, we do see that, oh, measurement of segment JK is equal to measurement of segment KL. Well, that's because K is the midpoint. And same thing with measurement of segment LM and MN being that M is the midpoint. So that's definition of midpoint. All right, definition of mid as well if you want. Number 3, segment JK is equal to measurement of segment MN. Oh, I don't see how that flows from this at all. Oh wait, it's actually a given. This one's ordered a little weirdly. Typically we put the givens at the front, so I'm sorry about that. But the givens really can occur anywhere in here. But typically we would put all that information in the front. Now we're probably going to use the information though if we just put it here. We're probably going to use that on step 4. So the fact that the measurement of segment MN is equal to the measurement of segment KL, and the measurement of segment LM is equal to the measurement of segment MN. Well, the second part we've seen before from step 2. What changed from step 2 to 4? Well, now measurement of segment JK is measurement of segment MN. That's because in step 3 we're told they're the same thing. So we substituted those two. And so we're going to put in parentheses what we did. So we did the substitution property. And what did we substitute? I substituted the measure of segment JK for the measurement of segment MN. Oh, and there's that nice little note there from what I call my school mom, Mrs. Moorhead there. I'll turn on Do Not Disturb, though, for the rest of the time. Segment LM is equal to segment KL. Well, we're told in the previous step, KL and MN and LM are both equal in measure to segment MN. Now they're equal to measure to each other. That looks to me like our transitive property. Two things are equal to both equal to the same third thing. Now they're equal to each other. So we use substitution property for out to cross out and transitive property. Segment KL is equal to segment LM. Well, we did from 5 to 6, we just flipped the order around. That's a symmetric property. And then last but not least, we have two segments having equal measure. Now they're congruent, which is going to be our definition of congruence every single time. Continuing on. We'll try number 5. On number 5, segment XY is congruent to segment UV, and segment YZ is congruent to segment TU. Well, let's mark what we know on our picture as well, okay? I think that can be very helpful. So XY is congruent to segment UV, XZ is congruent to segment, XZ is congruent to segment, or YZ is congruent to segment TU. Mixing up my letters. And so that is our given information in reason 1. And then we say, okay, well now instead of these segments being congruent, now their measures are equal. Definition of congruence. From here, it looks to me like xy plus y is equals xc. Let's go to our picture. Xy plus yz, yeah, that does give us xc. Look at the other one, segment tu plus segment uv, the measures, equal to measurement of segment tv. Oh, that's our segment addition postulate. If we had two parts of the segment, we get the entire segment. Okay. Now number 4, segment uv plus segment yz equals segment xz. Everything's the same here except for now segment xy is now segment uv. And we're told we can do that because in step 2 they are congruent to, or their measures are equal. So it's our substitution property. And it's that segment xy is equal to segment uv. Now wait a second. We actually have more going on. On the right hand side here, everything stays the same between these two equations of 3 and 4, except for segment tu is now segment yz. Well, if we look up at step 2, those were said that the measures were equal as well. So we actually catch here that we have a double substitution. So we'll list both in parentheses. Segment xz is now equal to measure segment tv. Well, segment xz, and segment tv are both equal to the same thing, uv plus yz, yz plus uv. You can add in any order. So that's our transitive property that they're now equal to each other. So their measures are equal to each other. So we have the segments are equal in measure. Now they're congruent. Definition of congruence. So all these take a lot of critical thinking and trying to explore, and maybe even trial and error of saying, what could get me from here to here, or what tells me that this is true, or what tells me that this is true, okay? We're actually going to skip number 6 for now, okay? So we're going to skip number 6 for now. Let's continue on to number 7. 7, this one, we have some stuff on the left missing, we have some stuff on the right missing, okay? So it's kind of a hodgepodge here. Now we're told in our picture that E is the midpoint of segment AC, and segment DE has an equal measure to segment EC. Let's mark that on the picture. E is the midpoint of AC. Well, we know it's going to mean that those two are congruent. And we're also told that segment DE has an equal measure to segment EC. Well, segment EC already has 1 mark on it, so segment DE can just match that with 1 mark. That can help us out later as we get to our table. Now, our statement, segment E, or point E is the midpoint of segment AC. Well, that's going to be our given. That's a nice freebie. Now in step 2, we're given a definition of midpoint of the reason. Well, we're told that E is the midpoint, and so we're going definitions. So that's probably going a lot of words here. Probably some math. We're going to have 2 things being equal. And it's going to have to deal with midpoint. So what do we know from E being the midpoint? Well, it's that the fact that the measure of segment AE is equal to the measurement of segment EC. Or CE if you'd prefer. But it's called EC later or earlier. So I would call it that. Now in step 3 we have our other given. This is going to be the given information we left out earlier. segment DE is equal to segment EC. Step 4, we're now told that segment AE is equal to measurement of segment DE. Well, if we look at steps 2 and 3, they were marked equal to each other. Our pictures look like that should be the case. We didn't have any given information that got us there right away. So this is actually our transitive property. Mr. Cosmo, could I use substitution? You betcha you can use substitution as well, okay? Just make sure you mark that you're saying what you're substituting. So now we're going to have definition of congruence. Well, definition of congruence is saying if two measures are equal, that the things are congruent, or vice versa. So these two measures are equal, so we have to be saying that segment AE is congruent to segment DE. And then in step 6, we have the same thing, but we flipped it around. So that's our symmetric property of equality, or the symmetric property of congruence, excuse me. So it would be the symmetric property. We'll continue on, we'll try number 8 here. I'll switch up colors. I'll go with brown. So now we're given the fact that segment RS is half of segment RT, and we're trying to prove that that means that S is the midpoint of segment RT. We might look at that and say logically, well, yeah, of course it would be. Or, oh, maybe it shouldn't be, but we have to actually prove it either way. So segment RS, measurement of segment RS is half the measurement of segment RT. That's given to us. So now we're told, if I take 2 times the measurement of segment RS, that'll give me the measurement of segment RT. Well, mathematically, what could happen here to get rid of this 1/2 and make a 2 happen on this side? We could multiply both sides by 2. So that could be our multiplication property of equality, as I write multiplication property of equality. Reason 3, segment addition postulate. Well, segment addition postulate, remember what that says is can be helpful, and it says that if you add 2 parts of a segment, you get the whole segment. So my 2 parts here would be measurement segment RS plus the measurement segment ST, and then give me the whole segment RT. Now in step 4, we're saying if I double segment RS, that's going to equal segment RS plus ST. Well, if I look at step 2 and 3, segment RT is told to be equal to both of these things. So our transitive property says that we can do that. Mr. Collins, can I also substitute? Yes, you can. Just make sure you put in parentheses what you're substituting. Oftentimes, transitive property and substitution property can be interchanged quite a bit. Every time, but a lot of the time. Number 5, segment RS is congruent to segment ST. Segment RS has an equal measurement to segment ST. Well, how could I get there? Well, if I subtract 1 RS from both these sides, this RS would simplify out, I'd be left with ST, and it get rid down from 2 RS to just 1 RS. So I took that and I subtracted RS, I'd get what is in step 5. That'd be the subtraction property of equality. Reminder that these are measurements. So measurements are numbers, so we can subtract numbers just fine. I'm taking 2RS equals RS plus ST, those segment measures. I'm going to subtract the measurement segment RS, subtract the measurement segment RS. 2 minus 1 is 1 measurement segment RS, those zero out. Measurement of segment ST, which brings us up to number 5. And last but not least, well, what we're trying to prove, that's a nice gimme. S is the midpoint of segment RT. And that is the definition of midpoint. Now if you look here, we went from math to a bunch of words with a definition. And what definition do we use? Midpoint. So our words are going to involve midpoint. So if R to S is equal measure from S to T, that means S has to be in the middle, or is the midpoint. Okay. We're going to try skipping number 9 and go on to 10. 10 is a problem where every single thing is blank on this now. Okay, everything is blank on this now. We'll try pink here, because on Wednesdays we wear pink. y is the midpoint of segment xz is our given. Okay. Well, a good thing can be marking on the picture. Y is the midpoint, so xy has to be congruent to yz. We're probably going to use that information later, that their measures are equal or they're congruent. So for statement 1, I'm going to put that y is the midpoint. Of segment XZ. And my reason? Well, it's given to me. Now I'm going to give you guys a hint right now that you don't have to use all the columns here. Okay? We're actually just going to use 6 of them. So if you're working ahead, you can, I just wrote 4 twice. If you're working ahead of me or trying to pause it and see what happens, see if you can figure it out, it's a great idea, but it's good to know that we're only going to be using 6 of these spots, so you don't pull your hair out, okay, trying to figure out what's going in the last spot. It is nothing. Meaning, in the spot 6, we can put what we're trying to prove, saying xy is equal to 1/2 the measure of segment XZ. Now, it might be helpful to realize that number 10, it looks like we're going kind of the opposite order of what we did on number 8, doesn't it? So that might be a helpful tool to kind of look at and realize we're going in the opposite order there. Now, we're told this is the midpoint. Now, let's try and use that information. Well, if this is the midpoint, we can say that segment XY is equal to measurement of segment YZ. So I'm going to put the measurement of segment XY is equal to the measurement of segment YZ. And I know that because of the definition of midpoint. Going a lot of words to a lot of math. Definition. In this case, definition of midpoint because it says midpoint. Now in step 3, well, what can I do? Well, let's say segment XY plus segment YZ equals what? If I add up segment XY and I add up segment YZ, what can I get? Segment XZ. And that would be the segment addition postulate. Now, at the end of the day, I'm going to be needing to get something where I have 2 times xy. I'm going to need something being 2 times xy at the end of the day. And I'm going to need that to equal xz, because it's going to be then I'll be able to divide by 2 to get this. And the reason I know I'm going to get that is not only because I'm the teacher, but because that's what we did here. If we're doing the opposite of what we did on number 8, and on 8, we started off with is equal to 1/2, and we had to multiply by 2 to get it there. So here we're going to have to get to this point where we have twice of something, we're going to divide by 2. So mathematically, I need 2 of my xy, 2 of the measurement of segment xy, equaling the measurement of segment xz. So if I take this step 2 and I add xy to both sides, that'd give me 2 times xy is equal to xy plus yz. How do you know how to do that? Well, it takes a lot of practice, and like I said, using number 8 as a resource and kind of keying in on the patterns we're seeing. And that is the addition property of equality, saying, hey, we can add the same thing to both sides of the equation and it still be true. So now if we look at steps 3 and step 4, if we look at steps 3 and step 4, I said it correctly. Sorry, I lost my train of thought. We have both 2xy and xz being equal to the same thing, xy plus yz. So we can say they're equal to each other. 2 times the measurement of segment xy is equal to measurement of segment xz. And that is our transitive property, or you could say it's a substitution, and write in parentheses what it is you're substituting. Now from 5 to 6, 2 times xy to normal xy, and xz to 1/2 xz. So if I divided both sides by 2, I would get there. So I'll do my division property of equality, because that says I can divide both sides by 2 and have it be a-okay. Like I said, that one's a pretty tough one. It really is, okay? It's pretty tough one. Takes a lot of outside the box thinking and a lot of practice to get to this level of knowing how to do these. All right, let's look at number 11 here. Let's go to gray. Let's try gray. So segment, and we will use all 8 of these boxes. I'll go ahead and say that. We'll use all 8 of the boxes, okay? And that's with putting both the givens in the same box. My pen was freaking out again there. I'll go and write in all of these real quick. Oh my, I just wrote 7 twice. Okay, well, let's mark our information on our picture. Segment AC is congruent to segment DF. That's a little tough to mark on here, so I might just avoid marking it because otherwise there's no good way to mark it without me thinking I'm talking about a different segment. Like, oh, maybe I'm talking about AB or maybe I'm talking about BC, and it gets confusing pretty quickly, okay? What about segment BC is congruent to segment DE? I can mark that pretty easily, so I'll do that. I'm trying to get to the fact that segment EB is congruent to segment EF. So let's first write down our givens. And I said all of our givens are going to be in one step here. Measurement of segment AC is congruent to segment DF. And the measurement of segment BC, or excuse me, segment BC is congruent to segment DE. And that is, of course, our given. We should also know one other freebie that we're trying to prove, goes in the bottom left, the last statement. Segment AB is congruent to segment EF. Okay, segment AB is equal to segment, or congruent to segment EF. So a lot of times what we've seen us do is go from things being congruent to things being equal in the very next step. And we'll do that exact thing here, saying, hey, the measurement of segment AC is equal to the measurement of segment DF. And also, the measurement of segment BC is equal to the measurement of segment DE. And what tells us we can do that is the definition of congruence. We've seen this a lot on our previous problems. So now we're told that those measures are equal, so now we can start manipulating them as needed, or we can move on to other measurements. Let's move on to some other measurements. If I take segment AB and I add segment BC to it, let's think about some things we've done in other problems. If I take segment AB, add the measure of segment BC to it, what would I get? Well, I'd get the measurement of segment AC, and what tells me I can do that is the segment addition postulate. A lot of times we have to look at our picture and say, what creative thing can I do? And then see if that will help us or not. Well, I can do that up here. Could I do that again on this line? You betcha. I can do that again on that line segment. Segment DE, or the measure of it, plus the measurement of segment EF will equal the measurement of segment DF. And that is, again, the segment addition postulate, or seg add post. Now on number 5, we're going to start using some of this information we were told earlier, where segment AC has an equal measure of segment DF, segment BC has an equal measure of segment DE, and we're going to take this equation in number 3 and, or rather, excuse me, we'll take the equation in number 3, and we are going to substitute a couple things here. So we'll leave AB the same. We're told that segment BC can substitute for segment DE. They're the same because they have the same measure. And we also have that segment AC has the same measure as segment DF. Now this is getting really creative and weird. I know you might be thinking, Mr. Costle, how do we know how to do this? It's going to take a lot of practice in order to start finding patterns that work for us. It's going to take a lot of creative thinking. So let's put down what we substitute, okay? So I'm going to put that as a substitution property. I'm going to put in parentheses that I substituted segment AC, the measure segment AC for the measurement segment DF, or excuse me, segment DE. Having this gray on here maybe was not a good idea. And that the measurement of segment AC has an equal measurement to the segment I already did that one. Sorry guys, I'm losing my biscuits, aren't I? The measurement of segment BC has an equal measure to the segment DE. Now how does that help us? Well, now we have two things equal to measurement of segment DF, both segment DE and plus segment measurement of segment EF, and the measurement of segment AB and the measurement of segment DE. So we can set those equal to each other. And then we might see just how this could help us. And we can do that using our transitive property, or we can do a substitution and write in what we substituted. Now from here we see the measurement segment DE appear on both sides. And this looks very similar to what we have from 6 to 8 as far as what's on the left side and what's on the right side if we take away those segment DEs, measurement segment Ds. So we can do that by subtracting. So I can say that the measurement segment AB is equal to the measurement of segment, I need to erase my pen there, is equal to the measurement of segment EF if I subtract measurement of segment DE from both sides. So that'll be my subtraction property of equality. So now I went from the segments having equal measures to them being congruent. So that's going to be, again, my definition of congruence. Because a lot of these properties we did, they don't work when things are congruent. They only work when things are equal. So we had to take it out of being congruent into being equal. And at the end, we had to put it back in because that's what we're trying to prove. Let's look at number 12, our very last one here. On this one, I'm going to use a different color than gray because that didn't work as well as I hoped. Let's try red. We are going to be using all 8 spots of this one as well. Another long one here. Now let's look at our picture and see if we can mark anything. We're told the measurement segment AB is congruent to segment CD. And we're trying to prove the segment AC is congruent to segment BD. Well, let's try it out. So given, we're going to write our given. Segment AB is congruent to segment CD. And that's our given. We also know our other freebie is our very last statement. That's what we're trying to prove. Segment AC is congruent to segment BD. Now, if we're talking about these segments being congruent, a lot of times our middle steps, we have to work with them being equal. So we are going to do the same thing we've been doing on a lot of these, where we start with them being congruent, now their measurements are equal. And we use the definition of congruence to get there. There is definitely a common theme amongst a lot of these. Now, just like we've seen on a lot of these, we're going to try using the segment addition postulate. The question is, I can add a lot of different things here. What would be helpful? Well, a couple different things are going to be helpful. If I take segment AB and I add segment BD to it, I'm going to get segment AD, the measurement of segment AD. That's my segment addition postulate. Now another thing that would be helpful if I go from segment AC and I add segment CD to that measurement of those, I'm going to get the measurement of segment AD. That's also going to be helpful to me. And we might see why right now, because in 3 and 4, we have both those things, segment AB and segment BD added together, and segment AC and measurement of segment CD being added together equal to the measurement of segment AD. So just like we did on proof number 11, on proof number 5, we could say that we can use the transit property to set them equal. But we're going to do our proof number 12. We could do that. But we're going to do one thing first here that's going to be more beneficial to us. Because what we need is AC on one side of the equation and BD on the other side of the equation, so we can say that they're congruent. In order to say that they're congruent, we need this exact same thing, but with an equal sign before it. And we can actually use that to help us and say, okay, well, in order to say that they're congruent, we're going to need the exact same thing before it with an equal sign, meaning we're going to use definition of congruence. Because we're going to have to get back from them being equal in order to be incongruent again somehow, and that's going to have to be it. So we know we're going to want AC on the left, we know we're going to want BD on the right. But we want to be able to do some sort of problem in order to get us to where we can maybe get rid of something on both sides of the equation, help us. So I'm going to take my second equation here, my AC plus measure segment CD and equals measurement segment AD, and I'm going to substitute in, instead of CD, I'm going to put in the measurement segment AB, and say that's equal to the measurement segment AD. And that's going to be a substitution property, and I'll put in parentheses what I substituted. So the segment AB was equal to the measurement of CD. Because we had that information earlier, it's a pretty big hint. We're going to use that somewhere. And up to this point, we hadn't. So now I'm going to use my transitive properties to have a lot of different things equaling the measurement of segment AD. And I'm going to need segment AC on the left and segment BD on the right. And these both, in step 3 and step 5, have measurement of segment AB being added. So I like that one the most. So I'm going to combine statements 3 and 5 using the transitive property, since they're both equal to measurement of segment AD there. So measurement of segment AC plus measurement of segment AB from step 5 equals, from step 3, measurement of segment AB plus measurement of segment BD. And that is our transitive property, because they're both equal to the measurement of segment AD. Now, from 6 to 7, if we subtract segment AB from both the sides, which is a pattern we've seen in a lot of these so far, we end up getting what we have in step 7, and we use definition of congruence to say that those segments have equal measure, they are congruent. Now this might be something that was really, really, really confusing to you, and that's okay. You might not be thinking that's okay, but it actually is. I don't expect you to get this right away. I truly don't, okay? It would be quite weird if you did. So don't panic over it if you don't get it right away. We're going to be practicing a lot more of these, okay? And so we're going to use more time to continue practicing these, and we're going to build time in to ask lots of questions as well, okay? So that way we can get used to this way of thinking that is really new to us. And we're trying, and there's a lot of trial and error, trying to find patterns and all of that good stuff, okay? So if you haven't already, make sure you go ahead and get that homework for me, okay? So if you haven't already, go ahead and get that homework for me. Have a great day.